Variability and its measurement in statistics. Variability, a fundamental concept in statistics, refers to the extent to which data points deviate from the average value. It measures the spread or dispersion of data in a distribution, indicating how much individual values differ from the mean. Understanding variability is crucial for interpreting data, making informed decisions, and conducting reliable statistical analyses. Types of variability. Biological variability. This type of variability arises from natural differences among individuals or within the same individual over time. It encompasses variations in physiological traits, genetics, and environmental factors. Real variability. When significant differences exist between observations, readings, or values of different classes or samples, exceeding predetermined limits, it is classified as real variability. Experimental variability. This type of variability results from errors or differences introduced during experimental procedures. These errors can arise from subjective or objective factors, such as observer biases or instrument inaccuracies, or from the sampling process itself. Measures of variability. Several statistical measures are commonly used to quantify variability. These measures provide a numerical representation of the spread or dispersion of data points, aiding in understanding the distribution of data. Range. The range represents the simplest measure of variability, calculated as the difference between the maximum and minimum values in a dataset. It provides a quick estimate of the spread but can be influenced by extreme values. Standard deviation. The standard deviation, SD, is a more robust measure of variability that takes into account all data points. It quantifies the average deviation of data points from the mean. A higher SD indicates greater variability, while a lower SD indicates data points closer to the mean. Standard error. The standard error, SE, measures the variability of the sample mean compared to the true population mean. It represents the uncertainty associated with the sample mean as an estimate of the population mean. A smaller SE indicates a more precise estimate. Range. The range, as a measure of variability, is calculated by subtracting the smallest value from the largest value in a dataset. It offers a quick and straightforward understanding of the spread of data but is sensitive to outliers, meaning extreme values can significantly impact the range. For instance, if we have a dataset of student heights, 150 centimeters, 160 centimeters, 170 centimeters, 180 centimeters, and 190 centimeters, the range would be calculated as 190 centimeters, 150 centimeters equals 40 centimeters. This indicates that the student heights vary by 40 centimeters. Standard deviation. The standard deviation is a more sophisticated measure of variability that considers the distance of each data point from the mean. It quantifies the average deviation from the mean, providing a more accurate representation of the spread of data compared to the range. The calculation of standard deviation involves the following steps. 1. Calculate the mean of the dataset. 2. Calculate the difference between each data point and the mean. 3. Square each difference. 4. Calculate the average of the squared differences. 5. Take the square root of the average of the squared differences. Standard error. The standard error, SE, is a statistical term that quantifies the accuracy with which a sample mean represents the true population mean. It measures the variability of the sample mean, indicating the uncertainty associated with using the sample mean to estimate the population mean. The standard error is calculated by dividing the standard deviation by the square root of the sample size. A smaller SE indicates a more precise estimate of the population mean, while a larger SE indicates a less precise estimate. Applications of variability measures. Variability measures find widespread applications in various fields, including scientific research, quality control, and finance. They play a crucial role in data interpretation, understanding the spread and distribution of data, statistical inference, drawing conclusions about populations based on samples, hypothesis testing, determining the significance of observed differences between groups, process control, monitoring and controlling the variability of processes, risk management, assessing the potential for variability in financial outcomes.